Welcome to this lesson on isotopes. Isotopes are a fundamental concept in modern physics and chemistry. In this video, we'll explore what isotopes are, how they differ from one another, and why they're important in science and everyday applications. Let's dive into the fascinating world of atomic variations. So, what exactly are isotopes? Isotopes are atoms of the same element that have identical atomic numbers but different mass numbers. In simpler terms, isotopes have the same number of protons in their nucleus, which is what defines the element, but they have different numbers of neutrons. This means that while they're chemically the same element, they have different masses. The key point to remember is same protons, different neutrons. There are two main ways to represent isotopes. The first is the standard form, where we write the mass number A as a superscript and the atomic number Z as a subscript before the element symbol. X, the mass number, is the total of protons plus neutrons, while the atomic number is just the number of protons. The second method is hyphen notation, which is simpler. We write the element name followed by a hyphen and the mass number. For example, carbon-12 or carbon-14. Both notations give us the same information about the isotope. Let's look at carbon isotopes to understand this better. Carbon has three important isotopes. Carbon-12 has 6 protons and 6 neutrons, making up 98.9% of all carbon on Earth. Carbon-13 has 6 protons and 7 neutrons, accounting for about 1.1%. Finally, carbon-14 has 6 protons and 8 neutrons, and it's radioactive. Notice that all three have 6 protons because they're all carbon, but the different neutron counts give them different masses. Hydrogen provides another excellent example of isotopes, and these isotopes even have special names. Protium is the most common form, with 1 proton and 0 neutrons, making up 99.98% of all hydrogen. Deuterium has 1 proton and 1 neutron, found in only 0.02% of hydrogen. Tritium has 1 proton and 2 neutrons and is radioactive. These three isotopes all behave chemically like hydrogen, but their mass differences make them useful for different applications. Isotopes fall into two main categories based on their stability. Stable isotopes have a balanced nuclear structure and do not undergo radioactive decay. They remain unchanged over time. Examples include carbon-12 and oxygen-16. On the other hand, radioactive isotopes, also called radioisotopes, have unstable nuclei that decay over time, emitting radiation in the process. Carbon-14 and uranium-235 are examples of radioactive isotopes. Both types are found naturally and have important uses. Isotopes have numerous practical applications that impact our daily lives. In medicine, radioactive isotopes are used for PET scans and cancer treatment through targeted radiation therapy. Archaeologists use carbon-14 dating to determine the age of ancient artifacts and fossils. Uranium-235 is essential for nuclear power generation, providing a clean energy source. In agriculture, isotopes help scientists trace nutrient uptake in plants and study soil composition. These are just a few examples of how isotopes benefit humanity. Let's summarize what we've learned about isotopes. First, isotopes have the same atomic number, meaning the same number of protons, but different mass numbers due to varying neutron counts. Second, different neutron counts change the mass of the atom but do not affect its chemical properties, since chemistry is determined by electrons and protons. Third, both stable and radioactive isotopes exist in nature, each with unique characteristics. Finally, isotopes have crucial applications in medicine, archaeological dating, energy production, and agriculture. Understanding isotopes is essential for grasping the complexity and versatility of matter at the atomic level.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.